Hello students, welcome to the class of cryptography and network security. We have already covered the fundamental of cryptography, the process of encryption, decryption and symmetric key cryptography and asymmetric key cryptography. In symmetric key cryptography, we saw that one single key can be used for encryption and same it is used for decryption. So today we're going to discuss asymmetric key cryptography where we need more than one key. Precisely two keys are used, and here two keys are named as private key and public key. So moving towards the actual part, this is me, Assis, and this semester I will take care of your cryptography and network security courses. I'll be there for your doubts and all. So in symmetric cryptography, we normally encrypt a message using a key and we got the ciphertext. And that ciphertext can be decrypted or we can got the plain text using the same key that is used for encryption, that key also used for decryption. But in asymmetric key cryptography, we need two keys. That's why the line has been written here. Symmetric key cryptography is based on sharing the secrecy. To understand these two lines, sorry, to understand these two lines, we need an example that will be best cited for this. Suppose you and your friends staying in a hostel and you have to get out from the room or go out to the outside from the room for any work, and in the meantime your friend is attending the classes in the university. So you lock the door and you took your own key. After some time your friends came back from the classes and your friends open that lock from his own key. Okay, both the keys are same in structure and both the keys are same in every aspect. So in symmetric key cryptography, you have shared the keys. So you send a message to someone, you just encrypt the message with a key. So you need to share that key to the someone to read that message. That's why symmetric key cryptography is based on sharing secrecy. You have to share the key to the person by which you are communicating secretly. But asymmetric key cryptography is based on personal secrecy. Asymmetric key cryptography is such a cryptography technique where you need one key for encrypting and you need your another key for decrypting or getting plain text from ciphertext. So in asymmetric key cryptography, there are two keys. One is known as a private key and another one is known as a public key. Due to this using of more than one key, this asymmetric key cryptography is known as secured algorithm. We'll discuss different algorithm in this class known as secured algorithm, and due to this asymmetric key cryptography are used more or less very effectively. The next image clear all the doubts between symmetric and asymmetric cryptography. So here is in this image Bob has a public key and it lock the algorithm or encrypt the data using Bob's public key. But it done at the side of Alice. Alice has encrypt the data using a public key that is available for both Alice and Bob. So the public key locks and the private key unlocks. Then the data sent to Bob. Then Bob on his own private key decrypt the message. So this is the beauty, this is the secrecy, this is the secureness of asymmetric key cryptography. If we take the pure idea of how the asymmetric key crypto system works in a real time, then this particular figure can clear this doubt. So the left side Alice is sitting and Alice is trying to send a message to Bob. So Alice just encrypt the plain text uses the public key. Let's have a pointer. So this plain text encrypted with this public key and it create this ciphertext. Okay, then this ciphertext gone through this insecure channel and this ciphertext received by Bob. Then Bob want to read that message, so Bob decrypt it using the decryption algorithm using his own private key and got the plain text. Now this is one part, but how this key has been distributed to different user or to Bob. So this key using a private key distribution channel, it just reached to the Bob using a key generation procedure, and this key generation procedure provides an algorithm to create a private key for Bob. So due to this particular key generation procedure, the Bob able to create a key and able to read the particular message. So let's have some example of asymmetric key cryptography. If we remember, so there are two algorithms for symmetric key cryptography, namely one is DES data encryption standard, and another one is advanced encryption standard, that is symmetric encryption. But asymmetric encryption, we have generally RSA crypto system. So RSA is nothing but this is the name of pre-developer. Okay, and RSA crypto system is works on prime numbers. So let's see how it works. So RSA normally uses two exponent E and D, where E is public and D is private. So we can say that RSA uses two key, one is E and another is D. Okay, so let's take P as the plain text and C is the ciphertext. So allies with sender. So C equal to P to the power E. This should be power P to the power E mod N to create ciphertext C from plaintext P. Bob uses P C to the power D mod N to retrieve plaintext sent by allies. So these are the formula. Next we'll see in figure how an RSA crypto system works. This is the symbolic, or this is the figure pictorial representation of RSA crypto system. So again, Alice is the sender. Plain text is available with Alice. Alice sending the plain text to the power E and mod N. Okay, as RSA crypto system using three algebraic structures, ring, star, and sets. So these things can be used like it is written there, R equal to Zn plus into. Again, the ciphertext has been generated and it is on a secure channel. It is going to Bob, then Bob getting the plain text using C to the power D mod N. Now, what is E and what is D? How E and D can be generated? So here it is written select P comma Q. So two prime number, big prime number they have taken, and just they are getting N equal to P into Q. Why they use the prime number? They use the prime number because prime number do not have any more divisible factor. Okay, so after getting P into Q, after getting N, then selecting E and D, so private D it's get decrypted. Okay, so one key calculation is there that is algebraic in nature. We'll see in detail in RSA crypto system. In this class, we only discuss different examples of asymmetric key encryption. So this is the example. Bob chooses 7 and 11 H, P and Q and calculates N is equal to 7 into 11, 77. Okay, Bob has chosen two prime numbers 7 and 11. Then as per the formula P into Q should be there. So 7 into 11, that is 77. Okay, then the value phi n, 7 minus 1 and 11 minus 1. So 7 minus 1 is 6, 11 minus 1 is 10. 10 into 6, that is 60. Now two components have to be chosen, E and D, from Z60. So when it is 60, I told you there is a set and ring structure. So from Z60 star, Bob has to choose the E and D. If he choose E to be 13 and D to be 37, and one more thing, it should be the prime number, because prime number make it more secure, make it more protective. Okay, so E into D mod 60 equal to 1. They are inverse of each other. So now imagine Alice wants to send the plaintext 5 to Bob. She uses the public exponent 13 to encrypt 5. So plaintext 5 is there. So 5 to the power 13 equal to 26 mod 77. Ciphertext would be 26. Bob received the ciphertext 26 and uses the private key 37 to decipher the text. So ciphertext 26, again this formula p to the power d. So p equal to 26, p to the power d would be 37 here. So 5 mod 77, plaintext would be 5. So the plaintext 5 sent by Alice is received as plaintext 5 by Bob. So this is the example of RSA crypto system. Next, we are moving towards the another crypto system that is asymmetric in nature, that is Robin crypto system. The Robin crypto system devised by M. Robin. It has been designed or developed by M. Robin. It is just a variation of RSA crypto system. RSA is based on exponentiation congruence. Robin is based on quadratic congruence. So here we need similarity. Instead of equal to, we need to put congruence modulo or similarity symbols. Okay, so let's move to the working part. In a Robin crypto system, it can be taught as a RSA crypto system which the value of E and D are fixed. So here E and D are fixed. That is, two keys are fixed. E should be 2 and D should be half. So in other words, the encryption is C congruence P square mod n, and the decryption is P congruence C to the power 1.2, that is C to the power half 0.5. This should be half. This is something like that, C to the power 1 by 2 mod 2, sorry, mod n. Okay, this is the thing. This is not C 1 by 2. This is C to the power 1 by 2. Let's see the figure so that it could be clear. So again, Alice is the sender and plaintext, that is convert into the ciphertext by the formula P to the power 2 mod n. And if someone wants to attack it, so it should be root of C mod n equal to root of C mod n, but it is infeasible. Then it goes with the secure channel. Then Bob in the receiver and Bob end, that P and Q has been calculated and that key has been generated, that is private. Then some calculation bearing on quadratic residues, as it is pure algebraic in structure, we are getting a plain text. We'll see how this algebraic structure can be worked. Next, we will see an example that will clear this particular figure. So here the example. Here Bob select P equal to 23, again in prime number, and Q equal to 7. Both are congruent to 3 and 4. Okay, then Bob calculates n equal to p into q. 73 is yes 161. Bob announces n publicly. He keeps p and q private. Alice wants to send the plaintext p equal to 24. So note that 161 and 24 are relatively prime. 24 is in Z161. So she calculate C equal to 24 square minus 24 square equal to 93 mod 161 and sends ciphertext 93 to Bob. Bob receives 93 and calculates four values. Because it is quadratic, the decryption part is quadratic in nature and some quadratic residues are there, so we calculate four values. A1 plus 93, 23 plus 1 divided by 4, this is the power mod 23, so this is 1, this is 1, 22, 4 and 3. So Bob takes four possible answer A1 comma B1 A2 comma B2 A2 comma B1 A2 comma B2 and uses the CRM Chinese remainder theorem to find four possible plain text 116, 24, 137, 45, all of them relatively prime to 161. Note that only second answer is Alice plain text. Bob need to make a decision based on the situation. Note also that all four of these answers when squared modulo n given the ciphertext 93 sent by the allies. So this should be so confusing. This would make the ciphertext so strong so that if someone attacks, it makes different types of plain text. That is the power of prime numbers. One more example we'll take, that is the Elgamal crypto system. We'll see all the crypto system in detail. In this class only we see the examples of different asymmetric algorithms or asymmetric crypto systems. So next we'll go to Elgamal crypto system. It is designed by Taher Elgamal and it is based on discrete logarithm. Moving to the figure, how it is working. Again, analyze the formula should be, there are two cipher. First one is from the plaintext C1 E1 to the power R mod P, then C1 equal to E2 to the power R dot P mod P, then that E1 dot E2 dot P, that will be creating another key and that key would be generated on the Bob side by using a very large prime number, and E1 should be selected as a primitive root. So E2 equal to E1D mod P. So the plain text, the ciphertext C1, C2 transferred to the Bob and in the Bob end, Bob got the plain text by the formula C2 dot C1 to the power D minus 2 mod P. So this is the formula getting the plain text. We'll see in detail in this particular crypto system asymmetric. So let's have the example first. In this example, the prime number is 11. Okay, then Bob chosen E1 as 2. Then the 2 is a primitive root in Z11. Bob then chooses D equal to 3 and calculates E2 equal to E1 to the power D equal to 8. So the public key roots are 2, 8 and 11. So the private key is 3 and Alice chooses R equal to 4 and calculate C1 and C2 for the plaintext 7. So by the formula, if the plaintext is 7, so C1 should be E1. E1 is here 16. Sorry, E1 should be 2. 2 to the power 4. Yes, R is 4. So 2 to the power 4. This is 16 mod 11. It is 5. Then C2 equal to P into E2 to the power R mod 11. 7 into 4096. So 6 mod 11. Then ciphertext would be 5 comma 6. And Bob receives the ciphertext 5 and 6. And that would be converted into plain text using the formula mentioned in this figure. So this is all about the asymmetric key cryptosystems. We'll discuss RSA, Robin cryptosystem and Algol cryptosystem in detail with the example, with the mathematical structure. If anyone has any doubt, do reach out to me. Thank you all. Have a nice day.